When we have a 0.910 molality calcium chloride solution, we have a freezing point of negative 0.440 degrees Celsius. We're asking what the Van-Hoff factor is. We have our freezing point constant for water of 1.86 kilograms per mole. Since it's an aqueous solution, we're in water. So the equation for freezing point depression is our freezing point depression is equal to IMKF. So Van-Hoff factor times molality times the freezing point depression constant. And this equation gives us a positive delta T. So normally to get the final freezing point, we're going to take the original freezing point and subtract off our delta T. So to solve this around for delta T, we end up with the original freezing point minus the actual for the solution. So we have 0.000 degrees Celsius for water minus the negative 0.440 degrees Celsius. So our delta T is a positive 0.440 degrees Celsius. We're looking for the Van-Hoff factor here. So I is going to be delta T over MKF. So we have a positive 0.440 degrees Celsius over the 0.0910 molality and the 1.86 degrees C kilogram per mole. So now we're just ready to run it through our calculator. And we end up with a 2.60 for our Van-Hoff factor. Our expected here would have been forming 1 calcium, 2 plus ion, plus 2 chloride ions. So our expected would be 3. And our actual will never be greater than our expected, but it can be less. So this one comes out to be less than the expected. It comes out to be a 2.6 for our Van-Hoff factor.